Okay, this is a problem that involves amortization or an annuity. This is actually an annuity side of it. You are contributing, and it's what we call an investment stage or an accumulation stage of an annuity, where you are putting money into it. And in that stage, the formula is the future value, that amount of money you're going to have at the end, which is what we're trying to find here, is equal to the payment times not 1, not 2, but 3 open parentheses. The book shows it as a fraction. Well, to enter it in your calculator, you got to have it in a line, in a single line. 1 plus our rate divided by n is the number of periods in a year, to the power of n times t, where t is our number of years, minus 1, close parentheses, divided by, open parentheses, our rate divided by the number of periods in a year, close parentheses, and close parentheses. See how easy that is? So the future value here is equal to that $200 per month times 1, 2, 3. 1 plus, what's our rate? 0.08 from the 8%, divided by, we are making that payment every month, so it's 12 times per year, to the power of 12 times, how many years? 30. Minus 1, close parentheses, divided by, open parentheses, 0.08 divided by 12. Close and close. You would hope so. You better hope so. I'll let you do it paper and pencil if you want to. So we've got our 200 times 1, 2, 3. 1 plus 0.08 divided by 12. Close, power. 12 times 30 is 360. I'm just going to do that. I got to arrow out of my power. Minus 1. Close divided by open. 0.08 divided by 12. Close and close. So you put $200 a month away. Every month. So that's $2,400 a year for 30 years. Anybody want to guess how much they're going to have? So this would be like starting at 35 and saving till you're 65. $298,000. $298,071.89. So about $300,000 if you save for 30 years. Now, the weird part is, let's say you do it for 40 years instead of 30. So 40 years is 480 payments. Anybody want to guess what that extra 10 years gives you? Well, 10 years is what? A third more, you're right? So maybe 400,000? If 30 years is 300,000, 40 years should be 400,000, right? Almost 700,000, way more than double.
For just 10 extra years.
For 10 extra years.
Wow.
That's what we were going after that yesterday. Remember that it's that 10 years, the 10 years is going at the beginning, so that money for those first 10 years is sitting there and it's compounding interest for 30 years. That'd be $1 million if we did it for 40 years.
Did you save for how many years?
That's 40 years. $300 a month for 40 years
40 years.
is $1 million.
4 years.
40.
40 years.
40 years. Let's see, you could retire at 72. Let's say you wanted to retire at 67. 35 years. We can put that in. 300. Is that what you're saving right now? Yeah. Not save anything? So 35 years, 35 times 12 is 420, right? 420 months. So what's 688,000? 690,000. Let's look at the other side of it. How much do you think you'd have to have per month to live off of in retirement? Now you think about it, when you retire, chances are your house is paid off. I mean, I have, what, 21 years to pay off my house yet. So by the time I'm 67, my house will be paid off easily.
Car insurance is probably super low.
Car insurance is probably low. You're probably not, you don't have to drive to work every day, so you don't have gas. You know, so I think about it, 2,000 a month, 25,000 a year, 24,000 a year isn't a stretch to live off of. Now, people think it's going to be a lot cheaper when they retire. The thing you got to remember is as you get older, your medical bills go up too. So that's the hard part to predict. Is you can predict that you're not going to have your house payment anymore. You can predict that you're not going to have your gas anymore, but there's going to be probably several $100s a month worth of prescription drugs and stuff like that you deal with. So let's say $24,000. That's $200 a month. How long do you expect to live? What age do you expect to die at? Put it that way. If you retire at 67, what age do you expect to die at? What age do you think you're going to live to? 87, 92, 104? Family history. Look at your family. What age do people tend to?
Not good.
No?
No, like 70.
70? Ouch. Well, then you don't have to worry about retirement. You're gonna work right up till you retire. Anybody want to throw a number out there? An age?
87.
87. So we're gonna look at 20 years. Now, when you retire, 20 years, of course, is 240 months. When you retire, you generally take those investments and put it into more conservative things. You're not getting that 8, 10% interest anymore. Probably getting 3, 4, 5% interest. So let's say it's going to be 4% interest, so 0.04. We're going to take our payment out every month, so we're going to do divided by 12. 20 years is 240 months, minus 1. Now this is going to be a little bit different here since you're drawing out. Up here, you were starting out with nothing and putting in that payment every month. So you're getting interest on nothing at first, and then the amount you're getting interest on grows and grows. Here, you're starting out with a large amount of money. You have a big pot of money, and you're getting interest on that big pot of money, and as you pull money out, we're taking out $200 a month instead of putting in $200 a month. Well, yeah, you're taking out the interest plus maybe a little bit of principal. So, but you're getting, since there's a large principal there, you're getting a lot more interest every month. So this is going to look a little bit different. This is going to be 0.04 divided by 12 times 1 plus 0.04 divided by 12 to the power of 240. Close and close. Well, let's have some fun. 200 times 123. 1 plus 0.04 divided by 12 power 240 minus 1 close divided by open 0.04 divided by 12 times open 1 plus 0.04 divided by 12 close power 240 close and close. You only need about $33,000 if you're only drawing out $200 a month for 20 years. That seems way off. I got a decimal point wrong somewhere there. Let me type that in again.
Man, who created this equation?
You know, the derivation of it is not as tough as you would think. I'll still come up with just 33,000. That's not terrible. What do you think? What's that? Yeah. Now the same formula, by the way, applies to a loan. So let's say you want to buy a $40,000 truck. We're going to divide instead of multiply here. Interest rate, let's say you got middle of the road credit, so you can get 5%. Divided by 12. How many years are you going to finance your truck for? 10? Usually 8 is the maximum they'll go. So let's go 96 months. So let's see what happens when we do that. 40,000 divided by 1, 2, 3. 96 months. Their payment, about $506 a month for 8 years. So times 96, that means that $40,000 vehicle costs you $49,000 because of the interest. So that's only at 5% interest. If you have bad credit, and that goes up to 7, 8%. I've seen people pay like 9% interest on a car. Actually, back in the 1990s, when interest rates were a lot higher, I saw people paying like 12 or 13% interest on cars. Your payment is $650. Yeah. Well, let's run it. A $40,000 car. Let's say that interest rate goes up to 10%. I'm guessing you weren't on an 8-year loan there either, but we're going to stick with 8 years just so we're consistent. Yep, going from 5% to 10% goes up about $101 a month.
So what's the total interest?
Oh, now you're going up to an extra $10,000 in interest by going up 1%. Not good.
Went up 5%.
Yep.
It was 10,000, extra 10,000.
Yep, because you were paying $48,600 before at 5%, paying $58,300 at 10%. So not quite $10,000, like $9,700 more. And that all goes off. That's your credit score that goes off of that. You have to actually have credit. You start out with credit cards, you make your payments. Now, the thing a lot of people don't realize about credit cards is, and I'm not claiming to be an expert, so. But if you don't have a credit and much credit and you don't have a credit rating, you get a credit card, you charge a few things on it, and you pay it off every month. Sometimes that doesn't build your credit score. So you charge a few things on it, and you leave a small balance. You make a minimum payment for a couple months, then pay it off. So now you've shown a balance on it. Your credit score, though, goes partially off of your available credit to what you're actually using. So if you've got a credit card with a $1,000 balance or $1,000 limit, and you've got $900 charged on it, that's actually bad for your credit score because you've got a limit of 1,000, you're using 900 of it. If you have a $100 balance on it, that's good because you've got $1,000 available and you're only using 100, which means you've got more available. You've got a cushion, and then you've got a history of making those payments. That helps. And then the different types of credit. Revolving credit, a credit card is revolving credit. Most of your store accounts would be revolving credit. Then there's asset-based credit. In other words, collateral-based. You would get a car loan, the car is collateral on the loan. You get a home loan, the home is collateral. Mortgages are in their own separate category. So if you have credit cards, you have a home mortgage, and you have a car loan, then you've hit all three of the categories. And now, for someone starting out, a lot of people don't realize this, and I don't remember the website you can go to, but if you look on the internet, you should be able to find it. There are websites. Most of the time, your utility bills do not report to a credit agency unless you get behind on your utility bills. If you get behind on your utility bills, then they will report you to a credit agency, sometimes, depending on the utility. If they turn you over to collections, they will almost always report you to a credit agency. So the biggest thing is don't ever get turned over to collections. But I know at least one website out there, I can't remember the name of it right now, but you can go to that website, you can actually register your electric bills and gas bills and stuff. You have to enter your account number and things like that. And what that'll do then is that crediting, that website will actually check with that utility every month. If your bill is paid, it'll report that to the credit agency, so you have a payment history built up on your utilities as well. That basically says if you're going to do that, then make sure you don't ever get behind on your utilities. Yeah, it's just a way, it doesn't do a lot for your credit, but it's a way of slowly building your credit if you don't have anything else out there. The other thing you can do if you're young is you can have your parents put you as a user on one of their credit cards. And then if your parents have good credit, then you inherit some of their credit rating if they put you on as a user on one of their accounts. There are a lot of ways that you can do, little ways you can help. It's hard to get started. And usually the easiest credit to get when you're young is credit cards. You just have to be very careful with it. You've got to carry a small balance for a few months, but don't let it get out of hand. Like right now, my credit cards don't do me any good because my credit cards never carry a balance. They're paid off every month. My credit cards are really just a way for me to avoid writing checks. Is all they are. Prepaid does nothing to help you because there is no record of it. A debit card doesn't do a whole lot to help you because it's coming out of an account where the money's already there. Yeah. You actually have to do something that you have to pay back, where you are actually indebted to somebody else. You're borrowing the money short term. It's called revolving credit. You're borrowing the money on a short term, but you have to pay it back.
So what if you just go through life without ever getting a credit rating?
There are people that do. They go through life without a credit rating. My dad's never taken a loan in his life. He paid cash for all of his cars. Old farmer. He bought a farm from somebody where he made payments to that person, not to a bank. It's very uncommon, but it's possible. Okay, our new stuff for today. By the way, today, I didn't realize it till I just looked ahead now. We are wrapping up Unit 2, which means next week, Tuesday, is Unit 2 test. So be aware. Unit 2 is going to be on fractions. And decimals, of course. So we're looking at today is we're looking at this thing. We've looked at this before. What does that mean right there? 8 cubed or 8 to the third power. How would you calculate it? Yeah, 3/8 multiplied together. 8 times 8 times 8. And you've all learned that button on your calculator. Most of you have a caret key. Some of you have an X to the Y or Y to the X key like that. Just to type in the 8, you press that key and you hit the 3 and it spits out 512. To make sure you guys know what button to use on your calculator, I propose a small race. 8 to the third power, you could just do 8 times 8 times 8 and get the answer. But if you give 2 to the 12th power, you don't really want to do 2 times 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 2. Try to remember, is that 11 or is that 12? What'd you get?
2 to the 12th power.
Yeah. 4,096. Good. I'll race you on this one. 15,625.
All right, man, you gotta say the number before you start writing.
How about 4 to the 5th power?
10 to 1. Syntax here. Loud. All right, one more.
One more? A little desperate, are we?
I got you.
You got me.
I got you. I got you on the ropes. Suck it in here. I got you.
I may have done these a few times before. As I've mentioned before, there are patterns in numbers, and once you start to see the patterns, the calculations are really simple.
All right, how about this one?
Oh, you're gonna test me with one that I don't know the pattern to, probably. What do you have?
58 to the 96th power.
That one's gonna be your calculator's gonna spit it out in scientific notation.
Then how about 22 to the 8th?
20 to the 8th, your calculator's gonna spit it out in scientific notation, most likely.
What about?
What that means when it does that, by the way, that E and then a number at the end, this is saying E to the E10. That's saying times 10 to the 10th power. The E means times 10 to the power of whatever that number is that follows it. So that is saying you take that 5.48758 and you move this decimal point 10 spots. That's 5, 6, 7, 8, 9, 10 to the right. So that's a big number.
How about 14 to the 5th?
Oh, shoot. I should know that one, too.
Oh.
You got me on that one. What is it?
537,824.
Okay. So anyway, we know how to work that button. All of the operations we have done so far, have an opposite. They come in pairs, like addition and subtraction. What do I mean about they come in pairs? Well, one is going forward, one is going in reverse. If I had, give me a random number between 1 and 10. 4. Okay. Give me another random number between 1 and 10. 1. Okay. So I take 4 and I add 1 to it, I get 5. If I want to take that 5 and get back to 4, what do I have to do? Subtract 1. Adding and subtracting are the opposite of each other. They reverse each other. If I add and then I turn around and subtract the same thing, I get back to where I started. Multiplication and division, same thing. Give me a random number between 1 and 10. 7. Another random number between 1 and 10. 5. 7 times 5 is 35. If I take that 35 and I want to get back to 7, I would have to divide by 5. Multiplying and dividing reverse each other. If I take 5 to the power of 4, I get 625. If I want to take 625 and get back to 5, not square root, it's a 4th power, 4th root. See, if I have 3 squared, that's 9, right? To get from 9 back to 3, I do the square root of 9, it'd be 3. There's nothing written here that makes that a square root. It's implied to be a square root. But if it's a power higher than 2, we've got to write it in there. It's called an index of that root. So what this is saying, the 4th root of 625 is saying what number to the 4th power equals 625, which is 5. So how do you enter that on your calculator?
Square root is just for 2. So then for
3rd root,
cubing, it would be the 3rd root.
like 7 to the 3rd power is 343. So the 3rd root of 343 is 7. On most of your calculators, it's above your power key. You have a key that looks like that, X root or N root.
Or would it be x to the negative power? Or is that
Is it -1?
yeah.
You might have a
He has a square root button and negative.
you might have a key that looks like this, Y to the 1 over X.
If I push shift, I got x over
This like this? Yeah. It should be shift. It should be above one of your keys. Whatever you might have your X to the Y key or caret key, whatever, it should be above that key.
Yep.
So to do a third rut, to do this one right here, you would type in 3 first. Then you push shift and then that key. Then type in the 343 and hit equals. On the graphing calculator, you got a, is that TI-84?
Yeah.
You got to go through the math menu. So you're going to type in the 3. Then you're going to press math. And I believe it's option number 5 is your X rut.
Yep.
So select option number 5. Then type in the 343
And it puts the 3 that you have
up in the index.
before you hit
Yep.
up in the-
So you type in the 343 and equals will give you 7.
Okay.
So try for me.
Can I copy that graph?
Sure. Well, he's copying that down. You guys can try to get that one to work for you. Try those two. See if we make your calculators do them. Good deal.
So then, what's that X to the Y power that you have circled?
That is like your caret key.
Okay.
Because usually that X root key is above your caret key on most calculators. The graphing calculator is different.
Yeah. Okay. Gotcha.
So you got this one to come out to be what? That is 5. How about this one? On a lot of your phone calculators, you have a key that looks like this.
No, I don't.
Okay. You got 2? Perfect. We're not going to do a lot with roots other than square roots in this class, just so you know. I just want you to be aware that they're out there. So, in your book, working on powers and roots, why don't you look at page 93, 1 through 21, the odds. And on Tuesday, shall be test 2.
Oh, I will have to agree with you that yours is pretty cute.